this is about a lot of drug things, at least this chapter. The former abbot of the San Francisco Center was a drug addict.
Okay, so I'm going to get started because we do have a few things to go over today. First of all, we have our first homework assignment related to subroutines, okay? Because I do want you guys to go through at least one homework assignment, and I have a chance to grade it before the actual exam too. Yep.
Like that a little more.
Like that?
Yes.
But the good thing is I'm not recording myself. I'm recording the screen, so it doesn't matter as much. Okay, so we have a mock test today. I will show you the questions. We have a homework assignment. The homework assignment is right here. It's called Sub 1. So let's take a look at the homework assignment first, and then we'll proceed with the test, or the practice test. Okay, the homework assignment is just like the other ones, so I want to just kind of emphasize again that it is important that you use LibreOffice or OpenOffice to work on your homework assignments, and make sure that your name is the author of that installation. Okay, most people remember, I would say 95% of people remember, they got a routine down, but I do have to emphasize it because some people still kind of forget about that occasionally. Okay, this one is not, it's using the wrong file because I forgot to upload the file. Okay, so I have to fix this first. It's not, the homework is not there yet. I forgot to upload the file, so it's still using the old file. But anyway, it's a recursive subroutine, about the same as the first one that we encountered. So it's not really complicated. But as of now, we cannot do the homework assignment, so I better hide it first, so you don't, no one is trying to do it right now. So I'm gonna hide it. There we go. Okay, so it's about the same as the first recursive algorithm that we have encountered. So if you look through the trace of that one, from YouTube, you probably can figure out how to get this one to work too. The only difference is, this time you have to actually do it, on a spreadsheet. So that's why, I think the concept will sink in a little bit better, with this particular homework assignment. The assignment itself is due next Thursday, so you have a week to do it. I don't think it will take you a week to do it, but that's just the usual way we do things here. You have a week to do it, but that means it's going to do on the same day as the original scheduled date for exam 2. So what I'm going to do is to postpone exam 2 to the following Tuesday. So that way, I'll give you the feedback for the homework assignment, and then you still have 1 weekend to study for exam 2.
So what date is that?
That's a good question. So we'll go to upcoming events. Exam 2 is now scheduled on the Tuesday of the 26th of November, 2 days before Thanksgiving.
You'll ruin my Thanksgiving.
Sorry? So that's the date. It's already showing in upcoming events. So that way you can see it when you log into Moodle. Okay. And here we actually have school or classes on Monday, Tuesday, and Wednesday in that week. Okay, unlike in elementary school and middle school, they have the entire week off, which is problematic because now who's going to watch my kids when they're home? I have to be here. All right, so that's the exam, and now we can move on to the practice exam, which is already uploaded here. It's just a document. So you can also open the document, download it, open it, and you have the same content as what will be displayed here. Okay, so let's go ahead and take a look at the practice test. The first question is your favorite pre and post condition stuff. So this time, it's the analysis of the following pseudocode. Okay, I think we have seen this code many times. I flipped the direction. Okay, I flipped the comparison, so it's a little bit different from the one before. So given the post condition is z equals 4 and y is less than x, what is the most specific precondition of pre1? Okay, so I want the most specific one. In other words, I don't want anyone to say pre1 is true. I want the most specific possible precondition for pre1. Okay. That part, you don't have to show me the steps. You can just kind of work your way backwards to figure out what is pre1. Given that is the precondition, so given your derivation or what you think is a pre1 is pre1, now use the forward condition derivation to derive post 5. Note that the post 5 derived this way may not be exactly the same as the given post 5. Be sure to explain each step, especially those of assignment statements. The steps carry points. Okay, so I don't just need the answer, I need the steps leading to the answer. Are there any questions about the nature of this question? Okay, nope. Okay, let's go ahead and do it. Okay, so I'm hoping that you guys still remember something about the pre and post conditions. Okay, what I'll do is I'm going to rewrite the entire algorithm here, so this way I don't have to go back and forth between two screens. That won't take a long time. 2.5 is and if. Okay, so what you're given with is this is post 5. Post 5 is z equals 4 and y is less than x. Okay. So here we have z equals 4 and y is less than x. All right. So the first thing you have to do is to work your way back to pre1, because I want you to tell me what you think pre1 should be, given this is post 5. Some of you can recognize right away and say, oh, right away I know something about y because z equals 4. But let's not worry about it at this point. We'll just go back one step at a time. Okay. It also helps if you draw a picture first, because if you draw a picture of a conditional statement, then it's easier to guide yourself back the steps and figure out what is P1. So a conditional statement is a branch. It has 2 branches. You can only take one branch at a time. And the 2 branches have to merge before they get out of the conditional statement. So what I'm telling you is at this point here, after the merge, we have z equals 4 and y is less than x. Okay? That's a post condition for the entire conditional statement. Given that is true, okay, I could have come from either side of the conditional statement. Is that right?
Yeah.
So that means I could have come from the then side. The then side is z is getting the value of x. The else part is z is getting the value of y. Okay, so that means the same condition could have come from here, or it could have come from here. I do not know which way I came from. So I can now say, well, let's pretend that maybe I came from this side. So this post condition is also the post condition of line 2. Okay, so we'll just say that let's say post 2 is post 5 because I could have come from that side. Okay? Any questions about this? Let's see whether it makes sense. Okay? Because if post 2 equals post 5, that also means that post 2 is z equals 4 and y is less than x. If post 2 is z equals 4 and y is less than x, maybe it's possible, but let's go ahead and see what happens when we push this a little bit to pre2. Okay, so knowing post 2 is z equals 4 and y is less than x, what do you think is pre2? So we are talking about this statement here. If I know that z equals 4 and y is less than x after this statement, what can I say about the condition before line 2 executes?
X is 4.
Y is less than x.
Well, that's interesting, right? Okay, let's take out let's take a look at these pieces and see which one we can just keep it the way it is. z equals 4 I cannot keep, because z gets x is going to destroy the original value of x and is irreversible. So knowing the value of z after the assignment, I have no way to retrieve the original value of z. Is that making any sense? Okay. If it's z gets z plus 1, then I can reverse it so that z equals 3 before the statement. But since the right-hand side of line 2 is not reversible, has no inverse function, I cannot say anything about the value of z before line 2. So that means z equals 4, I cannot say that anymore. What about y is less than x? Can I keep that as a precondition? In other words, does line 2 affect the relationship between y and x at all? Nope, does not affect that, so I can still keep it, right? Okay, so we'll keep that one. And if you want to, you can also infer that since z is getting the value of x, and then after the fact it has a value of 4, maybe we can then infer and say x equals to 4, which is okay. That's perfectly okay. But pre2 is in a tight spot because in order to get to pre2, I also need the condition of the conditional statement to be true. Is that making any sense? Because we are talking about the condition over here. If I come from this direction, it tells me that y is less than x and x equals 4. But if I come from this direction, it's telling me that x has to be less than y, and both conditions have to be agreeable in order to become the precondition of line 2. Are they agreeable?
No.
No. Okay, so that means the entire condition would look like this, but that is simply false. It is not possible for y to be less than x and x to be less than y at the same time. So that's why regardless of the values of x and y, the precondition of line 2 has to be false. What is that telling you about that particular branch, the then branch of this conditional statement?
Didn't get there that way.
It went the other way.
Exactly, we did not come to the junction from that path. Okay, that's okay. That's perfectly okay. Okay. So this means we did not come from the then branch. All right, let's look at the else branch. Okay, so let's say post 4 in this case is post 5, which is z equals 4 and y is less than x. Okay, would that be okay? I mean, can I say something about pre-4 in this case, knowing that after line 4 executes, z equals 4 and y is less than x? What can I say about pre-4? It's about the same thing, but not exactly the same. Can I keep the fact that x or y is less than x? Does line 4 affect x or y? No. So the fact that y is less than x after the assignment statement means that I can still keep it before the assignment statement, because the assignment statement does not affect x or y. I cannot keep the fact that z equals 4 because, hey, I have no way to reverse the operation to find out what the value of z was before line 4. Okay, so that part I have to get rid of. But I can still infer, because z got its value from y, so we can infer that y has a value of 4 at that point. And that's okay. Are we still doing okay so far? But in order to get to the else branch, it also means that the condition x is less than y has to be false. If x is less than y is false, okay, I'll just do it one step at a time. So we can say and, because now we're at the else branch, we also have to say that x is less than y is not true. Are we still doing okay at this point? And then we can rewrite this just a little bit. Okay, y is less than x, we can keep it the way it is. Y equals 4, we can keep it the way it is. And this one, we can kind of rewrite it as y is less than or equal to x. Because if it is not the case that x is less than y, then we can say the same thing by saying y is less than or equal to x. Can I simplify this a little bit? In other words, if you look at these two conditions, they look awfully similar and related to each other, and yet they are a little bit different. So is there a way to simplify the first two items here in the conjunction?
Yeah.
It's a conjunction, so we have to take the more restrictive one, given that one is completely containing the other one. Okay, if they do not have that relationship, like one is completely containing the other one, then we cannot use that trick. Yep.
So if you say 4 is less than or equal to x,
We can certainly say that, but the first thing is to simplify this one first, to basically say, we can keep just, y is less than x, right? Because we have to keep the more restrictive one. This is a conjunction. And then on top of that, we also know that y equals to 4 at this point. So we can, if you use, inference, you can also infer that x is greater than 4. Which is okay. I mean, that's just, pushing it one more step. All right. So knowing that this condition here is false, this condition here is y is less than x, and y equals 4, and 4 is less than x. What about this guy here? What about the precondition of everything? It's a disjunction of the two sides, okay? Because it's when I get all the way back to here, I would not know which side I come from either. So it would be a disjunction of these two sides. So that means pre1 is a disjunction of the two sides. It would be pre2 or pre4. It's just like going in a forward direction. Remember when we merge, we also have to use a disjunction. When we go backwards, we also have to use a disjunction, because by the time we get to pre1, we do not know which side we came from. But this one is actually pretty easy to figure out, because pre2 we already know it is just simply false, and then the other side is y is less than x and y equals 4. And the last one is really just inferred. We don't really have to state that explicitly, but we can, it doesn't hurt. Can I simplify that? False or something? Is there any way to simplify the expression? In the actual test, you would not have to simplify it, but it's helpful to actually be able to simplify this, because it's a lot easier.
Just get rid of the false.
Just get rid of the false and the disjunction, right? Because false is the identity of disjunction. False or anything is anything. Okay? So that's why we can simplify this and just say, okay, in the end it becomes just y is less than x and y equals 4. And if you want to, you can also state that x is greater than 4. But that's all that we can infer at this point. Everything up to this point, you don't have to show me the steps. This is the only part that I need to know, is pre1 is this condition here. You can stop at that point, because the other one can be inferred. Are we doing okay so far with this code, with this question up to this point? Now, yep.
Why is it that y is less than x instead of you're writing y is less than or equal to x?
Because in a conjunction, if you have one condition implying the other one, then the one that is doing the implication is the one that you need, because the other one can be implied, and therefore it is not needed in a conjunction. It's redundant. In other words, if you look at these two conditions here, if y is in fact less than x, it automatically makes y is less than or equal to x true. So it's not needed. But it's not the other way around. Yep, go ahead.
Isn't it the other way around? So like if y is less than or equal to x, then y is less than x is implied? Like
No, because if y is in fact less than or equal to x, then there is a chance that y equals x, which does not imply y is less than x. So that's why in a conjunction you keep the one that is implying the other one, but in a disjunction you keep the one that is being implied, because that one is the broader one. Yep.
It's kind of like that question I had on the first exam, where you had the dead branches with the less than.
Yep. It's definitely related to that. Yep. All right. So now we have to go forward and use all the derivation steps that we know to go forward to get to post 5 again. And this part you have to show all the steps. Okay. So to show all the steps means you have to say pre2 is pre1, and the condition being true, in this case it is x is less than y. And then what you can do is just do copy and paste this stuff here. Okay. But that automatically comes to a contradiction because it has y is less than x and also x is less than y. So this thing becomes false, which means the then branch is now a dead branch. Given the precondition that we have, the then branch is a dead branch. So if you want to, in this case, you can say the then branch is dead. So it's out of consideration. You don't have to bother to derive post 2 because if it's a dead branch, it's not going to execute anyway. So why bother with the post 2 derivation? Okay, so that means we can now move forward to pre4. Pre4 is pre1 and not x is less than y because the condition has to be false in order to get to the else branch. And then you can just expand this one just like last time. Y is less than or equal to x. And we already talked about how when we have a more restrictive version of this one, we can keep the restrictive one because of the conjunction. So now it is just simplified to this part here. And once we simplify all this stuff, that's it. I mean, we cannot simplify this any further. Now it's time to derive post 4. Post 4, to derive post 4, we have to look at the expression again in order to determine whether we should use a substitution operation or a forget operation. So the question you have to ask is, if I look at the right-hand side of this assignment statement as a function of the left, if I look at the right-hand side as a function of the left-hand side, is it reversible? That's the question. Okay. So to make it more clear, we'll basically say on line 4, okay, f of z, because z is the left-hand side, is y, okay, because y is just the right-hand side, is not reversible. No inverse function. Is that okay so far? I mean, does everybody understand why this function has no inverse function? Because it's mapping every possible value of z to a single value, which is the value of y at this point, okay, which is 4, okay? But it doesn't even matter whether we know it or not. It's mapping all the possible values of z to a single point. So that means if you start with that one single point, which is the value of z, there's no way to reverse back to the value of, excuse me, if you start with that one single point, which is f of z, there's no way to reverse it back to the original value of z. It's not reversible. Are we? Yeah, it's not possible because you have multiple values mapping to the same point. So if you, just because you know where that point is, doesn't give you any ability to reverse back to where did I come from. If you want an analogy of what is reversible and why it is important, look at this one here, okay, which has nothing to do with conditional statement. Okay, so do not confuse this with conditional statements. Okay, a function, let's say is function f here. One way to look at this is you can start with different values here, and then a function is just a convoluted map that will map certain values this way, this value over here, this one maybe all the way over here, and then this one all the way over here. So I'm hoping that you guys can see how this is all mapping. Okay. In this case, it's a one-to-one mapping. In other words, each value that I start from, okay, this is the original value, will map to a single destination. This guy maps all the way to here. This guy maps to here. this guy maps to here, this guy maps to here. Is that okay so far? It's just a map, okay? Tell me where you're starting, and I'll tell you where you're supposed to end. Okay, that's basically what a function is. But this is a special function because it is a one-to-one function. You start with a particular place, you end with a specific place that is unique to your starting point. Okay, what an inverse function is, if you look at an inverse function, which is represented by f to the power of -1, that's usually how we write an inverse function, is to say, well, tell me where you are at this point, and I'll be able to trace my way back to tell you where you started from. That's an inverse function. But in order for an inverse function to work, it has to be a one-to-one correspondence. Because if you have two values mapping to the same destination, then starting from the destination, you cannot trace your way back and say, I know for sure you came from here, because now I can say, well, you could have come from here, here, or here. I have no idea which one of the alternatives origins you came from. So that's why the inverse function is so important, because an inverse function has to be a one-to-one correspondence as well. Are we doing okay so far with the concept of what is a function and an inverse function? Okay, so in this case, we have no inverse function, because if you think about f of z equals to y, what it is really doing is it will map every single possible value of z to a single value of y. Every value possible with z, they all come to exactly the same point here. So starting with this point here, is it possible for me to reverse back and know for sure which spot I came from? It's not possible. There's no inverse function in this case. Yep.
So what you're saying is if y was 6, z would get it. And z would be mapped to a point, but you could go back to y getting it, but if it had 3, 5, 2, 8, you wouldn't know which one of those.
Given where you are at this point,
right,
there's no way to reverse back to the origin.
Right.
And that's why there's no inverse function, because an inverse function allows you to go back to a single point. Right. Tell me where you are now, and I know exactly where you came from. That's basically what an inverse function is. But in this case, it's not possible, because you could have come from any one of these points here, and there's no way for me to tell now that you're here. Okay. Any questions about this? I wonder whether in the math class they look at functions like this, just draw a little map thing. Because I think this is intuitive. I mean, this is actually quite intuitive and say.
Actually, they don't do it that way. They'll do it in a XY
table?
coordinate table.
Yeah, they can do it with the table too. But this one is very concrete, right? Yeah. I mean, it's very concrete. It's like, can you trace your way back? Nope. Okay, there's no inverse function. Well, I should say, can you trace your way back to a single point only? Then, the answer to the question. Okay, so if f of z equals y is not reversible, then we have to use the forget operation, because you just cannot use the substitution operation without an inverse function. So when you apply the forget operation, the post condition becomes a part of it comes from the precondition, but you have to forget about certain things here, because in this case we're changing the variable z. So everything that we knew about z, we kind of have to forget it. But at the same time, we can also say, well, because of the assignment statement, we also know that z equals y after the fact. So the z equals y part is outside of the forget operation. It's also important to remember that. So at this point, we are just going to copy and paste a little bit here. And because we are forgetting everything that we knew about z, do we have anything to forget? No, we don't have anything to forget. Because if you look at the precondition of line 4, it doesn't mention anything about z to begin with. So there's nothing to forget. We can just say, okay, we keep everything that we knew about all the variables. On top of that, we can just say, oh, we also know that z equals to y at this point because of the effect of the assignment statement. and then that's post 4. Post 5, on the other hand, is post 2 or post 4. But heck, this is not going to work because we know that the then branch, which is on line 2, coming out of line 2, is a dead branch. Doesn't that kind of negate the general equation that the post condition of a conditional statement is a disjunction of all the possible branches, or the post conditions of all the possible branches? The answer is no. Okay? We can still apply this. Because post 2 is just false. The entire branch is a dead branch, which means the entire branch has a post condition of false. Now, knowing that, we can now say, oh, post condition of line 2 is just false. Post condition of line, excuse me, the post condition of line 2 is false, but the post condition of line 4 is this thing here. And once again, we can apply the identity property of false with respect to disjunction and simplify this to just this one here, and we are done. Now, your derivation may be a little bit different because some people may do one extra step and say z equals to 4, which is okay. I'm not going to take any points off. I'm focusing more on the steps more so than the actual content, because the steps show me that you know how to process and analyze the problem. The final answer, you can get it in a different way, or it can be a little bit different, but still state exactly the same thing. So do we have any questions about this question in the practice test? No questions? Okay. If there are no questions, we'll move on to question number 2. Question number 2 is related to arrays, and it looks kind of funky. Assume that a bracket 0, the first element in array A, has a value of 2, the second one has a value of 0, the third one has a value of 3, and the fourth one has a value of 1. Evaluate the following expression, perform it one step at a time because the steps are worth points. And the expression I want you to evaluate is this: a bracket, a bracket, a bracket, a bracket, 0, close bracket, close bracket, close bracket, close bracket. Okay? I think we have seen something like this before. No? Maybe? Okay. Not yet. Okay. That's not a problem. We can do it. Okay, so let's take a look at this problem here. Okay? So we know a bracket 0 has a value of 2, a bracket 1 has a value of 0, a bracket 2 has a value of 3, if I remember correctly. Yep. And then a bracket 3 has a value of 1. That's given to you. We want to evaluate a open bracket, a open bracket, a open bracket, a open bracket, 0, close, 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 close. So how do we do this? Well, we have to do it one step at a time. Go ahead.
Or you just start subbing in values, basically.
One at a time.
One at a time. So where do we start?
Bracket 0.
All the way, the deepest part. Yep. Okay. So we just look at this thing, and then we can say this expression is asking a open bracket, a open bracket, a open bracket. But the first step is to resolve what this is. Okay? Because we know what 0 is already. So therefore, we can resolve what is a bracket 0. What is a bracket 0? That's given to you. It's 2. Okay. So now we have resolved the deepest level of this nesting of indexing. So the next one is to resolve the next one. What is a bracket 2?
3.
Okay. And now we can resolve what is a bracket 3? 1. Whoops. Okay. And then what is a bracket 1? 0. Okay, we're done. So we just do it one step at a time.
We shouldn't add the value.
Add.
The value like a bracket 0 to a bracket 2 0.
There's no adding. I don't see any addition operation here. I'm using the value of one array element as an index of another array element, and that in return becomes the index of another element. Yep. Row sheet. I could not print out the one for today, so we are going to reuse the one. So we have to add another column here. But you guys already know how to do that. So I'll let you guys do it. Okay, any other question about this particular question? No question?
That'd be like half the test.
It's half a minute. Make it bigger, yeah, make it longer, right? Well, you can probably see what's going to happen if I make it even longer, because you can see it's cyclic. Yeah, it's going to go. It's just going through the same sequence again, and then back to the same sequence, back to the same sequence. So it's not going to be very interesting in this case.
Do you want us to show our steps with that one?
Hmm?
Do you want us to show steps with that one?
Yep, I just
Okay.
showed you all the
Oh, yeah,
steps.
got it.
Yep,
I
one
see
step
what
at a time. So the first step is to resolve what is a bracket 0. The second step is to resolve what is a bracket 2, because a bracket 0 is 2,
Right.
and the value of the of element 0 is being used as the index of another element, and then the value of that element in return is being used as the index of another element, and then the value of that element becomes the index of yet another element. That's basically what it is.
Right.
It's really testing whether people understand the concept of what is the index of an element as opposed to what is the value of an element, and how you can use the value of one element as the index of another one. That's basically what it's testing. All right. Now that I have asked this question in the practice test, the actual test has to be a little bit different, right? So I'll leave it up to your imagination of what the actual question is going to be like. Okay, question number 3. Question number 3 is a little bit of tracing, but you don't have to trace the whole thing from the get-go. So I want you to I'll give you the algorithm, and then I tell you the following is a partial trace. Okay, so the partial trace is already kind of done here. Don't mind that the value of x and y may not make any sense, because we only have 4 elements. How can 4 plus 5 equals 9 when I have to add when I can only add 1 to x or y in the conditional statement, or none in some cases, as they can be pre-initialized. So I didn't tell you how the whole thing started. I'm just telling you that at this point I'm on line 1, and those are the values in my variables. Continue the trace for another iteration until we get back onto line 1 again. That's your job, okay? Is to trace it until we get back onto line 1. Okay, so let's go ahead and do this one and figure out, what it is supposed to do. I'm going to zoom out just one level so I can display both the algorithm and also the trace at the same time. So there we go. All right, so line 1 is completely traced for you already. Okay, we know that I is less than bar a bar minus 1 is true. So where do we go next?
2.
Line 2, yep, because we have to get into the loop here. And when we get to line 2, we have another condition to evaluate. We have a bracket I is less than a bracket I plus 1 to evaluate. Is that true or false at this point? I has a value of 1. How do I know I has a value of 1? The algorithm does not initialize at all. Well, it's already in the trace, right?
Yeah.
In the trace, if you look at column C, I currently has a value of 1. Okay, so I'm actually comparing a bracket 1 versus a bracket 2, because I plus 1 is 2. We doing okay so far with that? Okay, so keep in mind that, okay, I'm going to use the mouse pointer instead of my finger. So right here, the plus 1 is inside the square brackets. So that means the plus 1 affects the index, but not the value of the element in this case. Okay, a bracket 1 has a value of 1. A bracket 2 has a value of 1. 1 is less than 1 is false. Very good. Okay. So when the condition is false, what do? We go to the else portion, the else if, because this is a multi-branch conditional statement. So on line 4, we have something similar, except we are checking for one being greater than the other one. What do you think the result is?
False.
That is false as well. And then what do? We get to line 7, because I don't have an else to catch everything, everything else. So I have to get to line 7, because this is the end of the multi-branch conditional statement. Line 7 is just adding 1 to I increments from 1 to 2 in this case. Then we get back onto line 1, and you can just indicate I is less than bar A bar minus 1. It's still true because I is 2, bar A bar minus 1 is 3. So that's it. One iteration is all that I'm asking for. Any questions about this one? Now, even though you're only going through one iteration, I can already assess whether you understand the nature of a loop, the nature of a multi-branch conditional statement, how to do indexing, and also catching line 7 after the conditional statement. So there are multiple things that I can already assess just from one single question and only with one single iteration. All right, so that is that. Question number 4. Question number 4 is, even with short-circuited Boolean expression, the following code is still problematic. Okay, this is the code that I'm talking about here. Finish the following trace, but you have to start with filling in values of a bracket 0 and a bracket 1 so that the trace will attempt to access an element out of bound, then actually trace the algorithm until the problem happens. If you think the algorithm is fine and it is impossible to access an element out of bound, explain why you think so. Okay. All right. So let's take a quick look here at the trace and the algorithm. And you guys can tell me what I should put into a bracket 0 and a bracket 1 so that this program is going to have a problem. It will attempt to access an element out of bound. And I'm making this pretty much as simple as possible already.
It can't go on to the third element.
Right, but how do you structure what kind of values in a bracket 0 and a bracket 1 do I need in order to trigger the erroneous condition that is accessing something out of bound?
A bracket 0 needs to be larger than a bracket 1.
That will get me out of the loop in the first iteration, so the problem would not show up.
Okay.
I want the problem to show up. Yep.
Right. If you put 1 and 2 in for 0 and 1.
Yep. All I need to do is to guarantee in the first iteration the condition stays true. Then I have a chance to get to the second iteration. It's the second iteration that's going to cause the problem. Okay. So that you're absolutely right. Okay. So we go here and then we say, oh, let me see. Well, let me display both at the same time. Okay, there we go. All right, so the answer is to put a 1 here and a 2 here, okay? Anything, as long as the first one is less than the second one, it's going to work, okay? Because in this case, I start with line 1, I gets initialized to a 0. I go to line 2, I is less than bar A bar is true, because I is 0, 0 is less than 2 is true. And then the second one is a bracket 0 is less than a bracket 1, which is also true because the value of a bracket 0 is 1, and the value of a bracket 1 is 2. 1 is less than 2 is true. Okay. So we have true and true, so the whole thing is true. Then we go to line 3, and then we go back to line 2. And right here, we have I being, oops, I forgot one thing. When I went to line 3, I forgot to actually add 1 to I. Okay, now getting back to the condition here. I is now 1. Bar A bar is 2. 1 is less than 2 is true. So even with short-circuited evaluation, I am still forced to evaluate the right-hand side with a conjunction. Because with a conjunction, if the left-hand side is false, yes, I can bail right away because there's no way I can make this expression true anymore when one side is false already. But when the condition on the left-hand side is true, then I have to evaluate the right-hand side. Because if the right-hand side is true, then the whole thing is true. If the right-hand side is false, then the whole thing is false. So I have to evaluate the right-hand side in this case. But when I try to evaluate the right-hand side, I have to access a bracket 1, excuse me, a bracket I, but I is 1, so therefore I'm accessing a bracket 1, which is not a problem. Okay, the array does have element 1, but the other side of the comparison is attempting to access a bracket I plus 1. I is 1, 1 plus 1 is 2. In other words, I'm trying to access a bracket 2 in this case, which does not exist. The array only has 2 elements. Okay, so right at this point, it's going to crash, or it will do something that is incorrect because I'm accessing out of bound. Okay, so in this case, I can just say accesses an element out of bound. You can't see it because it's kind of hidden here. I can always stretch it out. There we go. Now we can see it. Is that okay? Does everybody understand? You can stop the trace right here because as soon as you access an element out of bound, you have answered the question. All I want.
The last part.
Yeah?
I didn't understand the last part. When you access element out of bound.
That means I'm accessing an element that does not exist in the array. The array only has 2 elements. I'm trying to access a 3rd element. A bracket 0, A bracket 1 are the only 2 elements in the array, but this is trying to access A bracket 2, which does not exist. Okay, any questions about this one? No questions? This one is a little bit fun because I can also test whether people can analyze the code and analytically figure out how to make it crash in this case. Yes, I remember that cartoon about I just want to learn how to do game programming. But I want to learn how to break those programs, not to write the programs. Breaking programs is far more fun. And people pay you more money to break something. Yep.
Did anyone figure out how to get the fingerprint out of the new iPhone yet? Out of the chip? There was like a prize for like $1 million if you can hack the firmware.
No, I do not know yet. I don't have an iPhone.
I don't like iPhone, but
I'm not planning to have any Apple products.
yeah.
All right, so this is the 5th question, which is the last one in the practice test. This one I really like. Also, I like all of my questions. Otherwise, I wouldn't be asking those questions, right? Okay, so let's take a look at the question text itself. Okay, the question text is quite simple. The following is a recursive version of the binary search algorithm, but not using local variables or parameters or any of that stuff. So the first thing you notice, or some people would notice, is to say, hey, this is mixing up subroutines and array indexing. So we have never talked about that in the class, and therefore I cannot answer that question. It's fine. I mean, it's like when you're building Lego blocks, you have been building Lego blocks using the rectangular 2x-something blocks, for years, okay? And then I give you some additional blocks that can rotate and turn and whatnot. Now I'm saying, okay, make something that use both types of blocks. It's okay. I mean, it's okay. These things actually plug in just fine without any problems. Now, if I make the array a parameter, then we have a new issue, okay? Because we have not talked about that before. So how do we, pass an array as a parameter by value and also by reference? Some of you can probably guess how it's done already, but that is a little bit different. This one is just using the array as a global variable. So we do things exactly the same way as before because those 2 concepts, okay, global variables, arrays, and subroutines are what we call orthogonal. I mean, they don't interfere with each other. Okay, so continue the following partial trace until both return line number columns are deallocated. And you look at this and go like, oh man, it's going to take me a year to get through this trace. Well, trust me, it's not going to take you a year because we are already at the end of the recursion, so we're just going to unwind things at this point. And with recursion, depending on the algorithm sometimes, unwinding usually is pretty quick, okay? All right, so let's go ahead and take a look at the trace. And I might need to shrink the magnification one more time just to make it fit. There we go. All right, so looking at the trace here, currently we are on line 2, and line 2 is done already, okay? At this point, line 2 is done already. Otherwise, I would have left M uninitialized, would be a blank at this point. So let's go ahead, after line 2, we go to what? Yeah, because in this case, it's not even in the conditional statement. We just go to the sequential statement next to it. Okay, so that one is asking a bracket m is less than k is, well, let's try to figure out, because now we need to know what m is and also what k is. M is 2, okay? K has a value of 2 as well. So a bracket m is referring to a bracket 2. What is the value of a bracket 2? 5. 5 is less than 2 is false, okay? And then where do we go? We go to line, come on, 5, because we have an else if here. Okay, so we have to get to line 5 first to see if that condition is true or not. A bracket m is greater than k is
True.
true. All right, then we get to line 6. Okay, remember you have to trace the lines that contain the conditions so that you can tell me why you are skipping or you're getting into the branch. Okay, on line 6 we are evaluating m minus 1. M is 2, 2 minus 1 is 1, and then we use that to update the value of e. So e becomes 1. Is that okay? That's binary search, the proper way to do binary search. Okay. And then after line 6, where do we go? We get to line 8 because there's a conditional statement after the first conditional statement. So this time we have to evaluate a bracket m is different from k. That's true, right? Because a bracket m is a bracket 2. A bracket 2 has a value of 5. K is 2. 5 is different from 2 is true. Okay? And because this is a conjunction, we have to now evaluate the other side because knowing that the left-hand side is true doesn't mean that we know the answer of the entire conjunction. So now we have to evaluate the right-hand side of the conjunction, which is b is less than or equal to e. B is 2, E is 1, so that is false. So that means the entire thing is false. Is that okay? If line 8 has a condition that is false, where do we go next? No. If the condition of the conditional statement is false, I don't have an else here, so where do we go?
1.
We go to line 11. Okay. We get to line 11, and line 11 is n-defined sub. What do we do on on such a line?
The next one.
Okay, we use the rightmost return line number to tell us where to continue. So we make a note of it. So this is telling me that we have to go back to line 11. Okay, so we write down line 11 here, and then we have no use of this line of this column anymore. So we say, okay, thank you very much, but you're not needed anymore. Right? And now we're back to line 11. Well, again, we're at n-defined sub. What do we do? The same thing. Look up the rightmost active return line number. In this case, it's column K. So we say, oh, okay, it's telling me to continue execution at post. Make a note of that, and then we can, once again, deallocate column K in this case. And then we continue execution at post, which means we're done. Finish line. All right, so are there any questions about this trace? It's a little bit shorter than you think, right? I mean, because you think about, wow, look at all that code. The program itself has 14 lines, But since I am already done with the first half of the trace, getting to the point where it's ready to return, so you're just dealing with the easier part of the trace. Now, as an exercise, don't turn it in because I'm not going to grade it. As an exercise, trace the algorithm from the beginning until we get to the condition of line 2 that is the starting point of this homework, of this question. Okay, so do that as an exercise, okay, just to see whether you can follow the algorithm and get to that point. Is that okay? Okay, don't turn it in. It's not a homework assignment, but I think it's going to be beneficial, to trace this, just so that you know how you can use recursion in conjunction with arrays and with an algorithm that you already know. Okay, it's binary search. We know binary search already, so that would be a good exercise. Definitely a good one. Yep.
If we do that,
backwards to find the preconditions?
Nope,
So
you just start with line 12.
Okay.
Start the entire thing from line 12 and then go forward, and you should get to this point eventually. And then the rest is really just the second half of the trace. All right.
You need the value of k, though.
Hmm?
Don't you still need the value of k?
Yeah, you can assume k is given to you. Yep. So k has a value. Same with the values in the array. So k and a, you can assume those are basically given in a precondition, and just leave m, b, and e as unknown when the algorithm starts. Right. So are there any questions about exam 2, which is now more than a week away, more than a week from today? Because it's the Tuesday right before Thanksgiving. No questions? Yep. Go ahead.
The pre and post stuff is, I keep forgetting that over and over. Can you go over that again?
The pre and post stuff is about analyzing the algorithm and be able to figure out things in either a backward way or forward way. So you have to understand the difficult part. I think the most difficult part is to figure out what the assignment statements are doing. In other words, is it reversible? Given the post condition, can I reverse it and figure out what is the precondition? Okay, because with if the right-hand side is reversible, if we're looking at this kind of picture, if you can reverse back, then you can basically keep the entire post condition in the precondition with minor adjustments.
Right.
On the other hand, if the assignment is more like this one, where you can start, there's no way to reverse back to the original value of a variable, then you have to say, okay, I give up, okay, because I cannot tell what the variable was before the assignment statement.
Right. The difference between the forget and the substitute command.
Exactly.
I remember that part. But
Yep.
it's-
Will you post the answer in the modem?
Well, everything is being screen recorded right now, so you can always watch it again. Take screenshots.
But I want to print it out.
Hmm?
I want to print it out.
Then freeze the frame and then print it out.
Control print screen.
Yep. I mean, this is already helping you to study. Okay, I'm not gonna give you the entire pile of stuff, so it's all prepared. You really have to do some work too. Yep.
Well, I knew how to do some of it, but just like after last homework, just more clicked, and it's a lot better now. So just keep at it. Once it clicks, it's a lot easier.
I would just do the
keep
whole
trying.
question again. I would just do the question again, and then compare that to the answer that I have here. Now remember, a lot of this stuff I do not need you to include it. In other words, everything from here all the way up to, I would say here, is just me showing you how I approach the problem. Okay? Because you can just say, oh, okay, I think pre-1 is blah 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 blah. Okay? But then you have to go forward, with all the derivation and be able to come to the conclusion that I think should be the conclusion of this algorithm. Okay? Is that answering your question? Are you concerned?
I just want to print out to read again and again to figure it out.
Well, this one is online. I mean, the question itself is online already.
I know it's online. It's not like when you have a copy to read.
But then send it to a printer. The question itself. It's on Moodle already. If you go to Moodle, and X2 mock, exam 2 mock is that's what we are looking at right now. Okay.
So which one was the final answer on that one?
Sorry?
Which one was the answer on that one? What was
The pre and post condition one?
yeah one?
The first question, okay, the answer is going to be from here all the way to over here. So that would be the answer that I'm expecting. And I'm also, going to go through, the code, your derivation, and see, whether the steps are correct. Because sometimes people make silly mistakes, in one step, and then that affects everything else.
But as long as people can show me that they know the steps and how to analyze and do all the derivation, they will still get partial credit for it. Okay. Any questions about this one? Now, exam 2 is just like exam 1. It's open book, open notes. Okay. One of my PM students, told me that she found it really helpful. Just the process of preparing the quote-unquote cheat sheet that you can bring to the exam, that process itself was helpful because you're going through all the notes, you're going through the sample programs, the YouTube stuff and whatnot, and you're jotting down what you think is important. Now, I cannot tell you what is important because your mind works differently from mine. Okay, so what is important to one person because it's like, oh, this is a key concept. I kept missing this one, and I need to write it down on a piece of paper. Can be just natural to the other person, but the other person may find some other things more challenging and have to write it down on a piece of paper. So going through the process to basically have a condensed version of the notes was really helpful to the student who talked to me in the PM class. So that's why I strongly recommend you guys to do the same thing. Yep.
I hate to admit that I take horrible notes, but when I go back looking through your Prof's channel, your videos are labeled with the date and time of our class.
Yes.
There's no description. Like if I wanted to go back and go over the original video from our pre and post editions, I wouldn't know how to find it.
Just surf.
Yeah,
Yep.
how many channels,
Well, there's only 18 weeks, which is 36 classes, so I mean.
Do a binary search.
Oh,
Yep.
there we go.
It
That's
doesn't take
perfect.
that long.
Yes,
It
binary
really
search
doesn't take
works.
long.
Okay, but you are okay. Whoever mentioned who mentioned binary search first? That's great. Okay, it is a great idea because you know the ordering. Okay. Yep.
Start halfway through, and then you
Start halfway
backwards
through.
or forwards.
Yep. Exactly. Yep. Go
I was
ahead.
just wondering, after our test, we only have 4 class meetings before the final, so are
Yep.
we learning more content? Are we just doing
Yes.
a review?
Oh yeah, we have more concepts.
The
We
final
definitely
is
have more
cumulative.
concepts to go before the final exam.
And then the final is cumulative.
The final is cumulative. In a class like this, it's pretty hard not to be cumulative. In other words, I cannot easily ask questions about subroutines, but without asking conditional statements. Yep.
Are you gonna have a practice final?
Yes, there will be a practice final like a week before the actual final exam as well. Yep.
They're going to be pre and post on the finals.
Yes, there will be at least one question of pre and post condition in the final exam. Yes.
Worth a shot.
Okay. So any other questions? Come on. Yep.
How many questions is the final going to be?
The final exam is a 2-hour exam, so it's 120 minutes instead of 80 minutes. So you can expect a proportional increase in terms of the number of questions, but not necessarily the difficulty level of the questions.
So they're going to be like twice as many as like the
No.
midterm?
It's 120 minutes versus 80, so you're expecting 50% more questions, basically.
Do we have the date and time for our final yet?
Yes, we do.
It's on D2L.
It's on the syllabus. It's also on the website. Okay, this is. It's on your birthday. Great. That means it can be a birthday gift or something else, right?
It's December 19th. The spring class.
Okay, so you just look for the final exam schedule. Okay. So this is a universal way to find out your exam time and place for all of your final exam. This is a Monday, Wednesday class. We start at 10:30, so that means the start time
It's a Tuesday, Thursday class.
is. Oh, this is Tuesday. Okay, thank you for the correction. So this is our final schedule. Because this is a Tuesday, Thursday class, the start time is between 9:30 and 10:40 a.m. So we are going to have our final exam on the 19th, the Thursday, and the time is going to be from 10:15 to 12:15. So it's a 2-hour exam, but once again, the final exam is just a longer version of your midterms. It's open book, open notes, pretty much the same way. Yep.
I get 2 teeth extracted on that day.
Uh-oh.
Can I go to one of the other classes?
The PM class? Yeah, you can probably go to the PM class, but then you have to look up the PM class exam
It's
schedule.
just down a little further.
Yep.
I'll talk to you about that.
Talk to me about that, yeah, for that, for medical purposes, I can definitely.
Yeah, it's already set, it's like 4 years in waiting, so I'm not.
And you're not looking forward to it either.
No, I am.
You are.
Yeah,
You are.
I didn't get out, it hurt.
Yep. Okay. Any other questions about exam 2? Yep.
Will you let us in late? Because I get out of my first class at 10:15.
The first exam should let you out earlier than 10:15.
They stagger it, so your classes do not mix.
Yeah, you
They
can
don't
see
mix.
the early
Finals.
exam should end at 10 o'clock exactly and not 10:15. Are you sure your first exam is ending at 10:15 because they are not supposed to go over?
No, my first class. So if that's
But
the day
it's final week. You don't have a class on that day,
Yeah.
Okay.
unless it's not from this campus. Okay. Any other questions? No other questions? All right. Well, if you do have any questions, just bring it up, later on. And I took a screenshot of the previous class, so this way I can remind myself, where we are at, with respect to parameters. So we are just starting to talk about parameters in this case, using by value parameters. So it's time to move on, and revisit factorial, but this time make use of by value parameters. I think I haven't done that in this class, right? Factorial making use of by value parameters.
We started. We did a little bit of it last class. We went over it a little bit.
Okay.
Like the last 5 minutes.
Yeah, so I think we should start with that one, okay? Because it's a continuation of what we talked about the other day. So once again, we are defining, factorial. This time we have a by value parameter. Now, by value parameters are very useful as an inbox. So in this case, our inbox is n, which is I want to find the factorial of this number. Okay, this is my inbox. So once again, we say if n is 0, then the answer is easy. Now, just as by value parameters are not useful for returning results. Okay, I will explain that later on with another example. So in order to get a result back to whoever invoked factorial, I still need to rely on a global variable in this case, which is r. And then the other one is just to invoke the factorial program again, the factorial subroutine again. So we say invoke factorial, but this time we use n minus 2 to specify the new n, because I break the big problem down into a smaller problem. Okay, which is the factorial of n minus 1. When factorial returns, in this case, r will have the factorial of n minus 1, which means in order to figure out the factorial of n, I just have to multiply the factorial of n minus 1, which is now in variable r, by n itself. And if n define sub, and that's all that I need to do. So in order to run this program, I'm going to use a single invoke statement from the outside, and I'll just say invoke factorial 3 specifies n. And that's my entire algorithm. I think we might have seen the algorithm in the previous class, but I don't think I have traced it yet. Is that correct?
I thought you got this far.
We traced it already?
Yeah, I think so. We can trace it.
Okay, I think yeah. Have we talked about by reference parameters?
No.
Okay, so we haven't talked about by reference parameters. So let's scratch this one, and then we'll start a new one. Okay. Have we defined the swap subroutine? No. Okay. So we'll have by x, by value by x, by value y, local variable t, x gets the value, oops, t gets the value of x gets the value of y gets the value of t, and define sub. Does that code look a little bit familiar? No? Well, we'll figure out what it does. Okay. And I'm going to avoid the use of global variables altogether. So I'm going to define a subroutine called main. And in main, I have local variable I, local variable j. I gets a value of 5, j gets a value of 7. Invoke swap. And I use I to specify parameter x. I use j to specify parameter y. And define sub, invoke main. And that's my entire algorithm here. All right. I think it kind of follows that I have not talked about the significance of the main subroutine in this class. Okay. When you're writing programs in C and C++, also in Java and most languages that are derived from C directly, you cannot have any code that is outside of the definition of a subroutine. Let me say that again. In C and C++, you cannot have any code, any line of statements that is outside of the definition of a subroutine. But isn't that a problem? Because in this class, when we trace algorithms, we start with the very first line that is not inside the definition of a subroutine. But if you cannot have any code that is not inside a subroutine, how do we get started with the entire program?
There is a special subroutine that's called automatically.
Yes, and it's called the main subroutine, exactly. So this is to emulate, what you will be experiencing in CISP360, which is, we start execution with the main subroutine. Okay. In other words, you can kind of imagine that the operating system is calling or invoking the main subroutine. Okay. So there's an imaginary thing that is invoking main. So what you need to do is whatever you want to do. Okay. You start with the main subroutine. So this is just to emulate, that particular effect in C and C++ program. And then we'll go ahead and open a new window for the trace. We don't have any conditions to evaluate in this case, so we'll start with a line number. And we don't have any global variables anymore. Now, how do I know there are no global variables? I have to go through each and every subroutine, look at each and every single name that I refer to and say, well, is it declared as a parameter or a local variable? Okay? If it is either a parameter or a local variable, then I know it's not a global variable. So we start with swap here. Okay? We start with the name t. T is a local variable. We start with it, then we move on to the name x. X is a by-value parameter. Y is also a by-value parameter. So all the names that I refer to in swap are now accounted for, and they're not global variables. Is that okay? Then we move on to main. I have variable I here, which is a local variable. I have j, which is a local variable, and that's it. X and y are names of the parameters of swap, so they are not, they do not belong to main. All right, so we do have every name accounted for, and there are no global variables, which is good. Okay, I do not like the use of global variables, and this is the way to avoid it. Okay, now we start execution on line 16, just to be consistent with what we talk about in this class. But remember, in the C and C++ class, we just start with line 12 inside the main subroutine. But in this class, just to be consistent, I'm starting with line 16. We remember the return line number to be posed, and then we have to allocate for each local variable I and j. And because they are global variables, they start with unknown values, represented by question marks. And then we continue execution inside the subroutine main, starting on line 12. Line 12 is initializing I to 5. Line 13 is initializing j to 7. And then on line 14, we invoke the subroutine called swap. Once again, we need a return line number. And the return line number is just the line below or after the invoke statement, which is in this case line 15. And then we have two parameters and a local variable to allocate. Parameters are x and y. Local variable is t. So each one needs its own column so that we have 3 new columns to allocate. X is specified by I, which is the n expression. I currently has a value of 5. So that's why x as a parameter starts with a value of 5. Y, on the other hand, is specified by the expression j. J currently has a value of 7, so y as a parameter starts with a value of 7. T, on the other hand, is a local variable, so it starts with an unknown value represented by a question mark. Are we doing okay so far at this point? Okay, no new concept at this point. In fact, this entire example doesn't have any new concept. It's actually the precursor of a new concept, why we need a new concept. Now we continue execution in the subroutine starting on line 5. Okay, just 3 really general assignment statements. T gets the value of x, so T is now 5. On line 6, x gets the value of y. Y has a value of 7 at this point, so x becomes 7. And then on line 7, we change y, so it has a value. It has the value of t. So t has a value of 5 at this point, so y gets a value of 5 at this point. So at this point, if you just look at the values of x and y at this point, they are exchanged from their initial values. Is that okay? So those 3 assignment statements are just really for exchanging the values of 2 things, or 2 variables, 2 parameters, and so on. After line 7, we get to line 8. Line 8 looks up the return line number, makes a note of we have to continue execution on line 15, and then we have no use of the 4 columns that we allocated for this invocation. So we get rid of those 4 columns, we deallocate the 4 columns. And now we continue execution on line 15. Line 15 itself is also n-defined sub, so we look up the rightmost active return line number. It tells us to continue execution at post, and then we have no use of those 3 columns anymore. And then we say deallocate those 3 columns, and then now we are at post, which means we are all done. Did this algorithm do anything to local variables I and j? If you look at the values of I and j, other than the initializations on line 12 and 13, did swap as a subroutine exchange the values of I and j? No, not at all. So the subroutine doesn't really do anything then. Okay, it's not to the main subroutine. The swap subroutine didn't do a single thing, right? And why do you think it didn't do a single thing? From the trace here, why do you think nothing happened to variables I and j in swap?
Didn't return anything.
It's because the
parameter
the parameter is a clone, is a copy of the expression I and the expression j. So you can do whatever you want with the copy.
They all get destroyed unless you do it.
Exactly, they all get destroyed, and as a result, nothing happened to the original. Right. Okay, to fix this problem, okay, we are running out of time today, but this is something that you should read ahead of me, is by reference parameters. To fix this problem, I only need 4 changes. Okay, the first 2 changes have to do with the 2 parameters, x and y, and then the 3rd and the 4th change is really kind of syntactical. I'm just changing the single arrow that is pointing to the right-hand side to a double-sided arrow that is pointing in both directions. That's it. This is a syntactical change, but this will change the behavior of the program a lot. Okay, so it is up to you, to read ahead of me, so that on Tuesday we'll talk about pass by reference parameters. Okay, now that is a concept that can be a little bit difficult to understand. So I do recommend that everybody read ahead of me first, as much as possible on pass by reference parameters.
So there is no return command here? We're not using return command?
We're not using return.
Huh?
We are not using return. We are using pass by reference to address this problem.